All right, so composition of functions. Did I hit reply? All right. So composition of functions. This is a unique situation of combining functions. Okay. Basically, what's going to happen here is we are going to take a function. So basically, what we've been doing is taking an input value and run it through a function, right? So if I ask you like f of 2, you're going to take 2 and run it through f, right? Okay. Now what I'm going to do is instead of that 2, instead of giving you 2, I'm going to give you another function. I'm going to say take this function, the second function, and run it through the first function. All right. It's not all that difficult. It's not all that terrible. And being able to recognize maybe the functions that create a composition will help us eventually in calculus kind of do some of the differentiation, the integration that exists inside calculus. But just an example here, this is kind of the notation that we're going to use and see most of the time. It says we're going to name, and I don't really care that we name this thing h of x. It's this final product we're calling h of x. But it's being developed by taking your function f, we read this f of g of x, or f composed with g of x. Okay? And all it means is that you look at the innermost function. Do you guys agree that this is the innermost or inside function? Okay? You determine what that is. You go up and say, okay, what is my input? My input was x squared plus 1. So I just replaced g of x with x squared plus 1, right? Do that one iteration of substitution. And now my rule says, well, let's find f of x squared plus 1. Well, we've already done that. We did that earlier when we just started doing functions, and we said, like, you know, they ask you to evaluate f of 2, f of 3, and then you go f of a, and they ask you f of a plus 1. We did those questions with f of a plus h, right? That kind of makes sense? We were kind of doing the algebra that's necessary here. We now have an input of x squared plus 1. I'm now going to take that and say, okay, go find f. So f is radical x. And wherever you see your variable in f, replace it now with that quantity, x squared plus 1. And you see how that yields the root x squared plus 1? Okay. That's called a composite function. Okay. Now the way this works, in regards to the values that we're allowed to use, okay, think about this. We're asking, essentially, these x's are real numbers, right? So if I just did this question, if I asked you what f of g of 2 was, okay, you're plugging in 2 into g first, right? What's that give me if I take that 2 and plug it into g? 5. So this thing would produce a 5. G of 2 is 5. So I replace that. Okay. Now what's this say? Find f of 5. If I go f and plug in 5, what do I get? Radical 5, right? Okay. Is that the same thing I get if I do this right here? If I go f of g of 2 with this algebraic rule, plug 2 in there, you get 4 plus 1, right? Is that 5? You get root 5. Now here's the idea. We're talking about the domains of this thing. Now, there are no issues with the domains here. But let's say if I go f of g of 3. Let's say 3 is a violation to this thing. Let's say 3 does not belong to this domain for some reason. Okay? Would I have an output value then when I plug 3 into this? Does that make sense? Okay, so let's actually rewrite. Let's give a specific. Let's say this is 1 over x minus 3. Now this would not make sense. If I go f of g of 3, plug in 3 here, you get 1 divided by 0, right? You get undefined. Can I put an undefined value? Can I take an undefined value and run it through f now? No. Okay? So when we analyze our domains for composite functions, the first thing we have to do is look at that initial inside function domain. Okay? And that's going to be a huge part of our final domain. So we look at that and see if there's any restrictions with that. And then when we're done and we come up with our final production, we need to make sure that if there's any issues with that domain. So we'll see some examples of that. That's kind of what I want to target today, is working with the domains of these things and understanding the domains of these functions. A lot of times they describe functions. You probably did this in Algebra 1. They call it a machine, and they say, okay, I'm going to take this machine, I'm going to run something through it, and see what it kicks back out to me. Okay, so I always use like the idea of like a food processor. Okay, if I take a potato, run it through a food processor, maybe I get some hash browns, right? The idea then is I'm going to take those hash browns now, I'm going to run them through another machine, maybe it's a fryer, and when I get an output now of some cooked hash browns, right? Okay, does that make sense? So the idea is that a composite function should be those two machines together at once, meaning that I put a whole raw potato in and it spits back hot hash browns to me. Okay, and that's what's going on here. Okay, and it's also being described here, kind of visually with a map. It says if I look at the blue set of input values, I can take those input values and run through the function g, and it gives me the purple outputs, right? Those purple outputs now become an input value for a second function f. And when I run those through f, I get the final output that shows up in that orange bubble, right? Well, that's going through two separate machines. The idea of a composite says take your value from your blue bubble, take your blue input value, run it through f composed of g, and it automatically spits out your output for the composite. Okay, it effectively runs it through two machines. So that's kind of the logic or the understanding of what we're doing here. This here is the explanation of the domains that I said. And it's kind of hard, I think, to analyze this in general, given any two functions f and g. We start with a number x in the domain of g. So that means we have to look at g, the inside function, okay? And the x values that we choose have to be defined for that, or we're not going to be able to get an output, okay? So it says we start with a number x in the domain of g and find its image g of x. Its image is just its output, okay? Another way of saying that. So if this number g of x is in the domain of f, we can then calculate the value of f. We can then run that through f, okay? It says the result is a new function, h of x, we define as f of g of x, or f composed of g of x. That's how we read this, okay? They're defining it down here. It says given two functions f and g. Zoom in on it for you, maybe. All right. So given two functions f and g, the composite function f open dot. That open dot is read as composed with g, or f composite g, or the composition of f and g. Does that make sense? That open dot does not mean multiplication. Okay? Does not mean multiplication. And a lot of times that's the way they're going to write it in like a homework or a test or a quiz. And you're going to have to figure out what you're comfortable with, but I'm not comfortable with that. Okay? Now, the fact I've been doing this for about 15 years, I'm comfortable with it, but if I had to choose, I'd go that route. Okay? Because it's more, I think it's more obvious. So they're going to tell you, if I've got maybe h composed with r of x, okay? I think it's better for you to kind of work your way from left to right, saying h, and then you put a parenthesis. So you've used h, right? And now you go to r, okay? Use r, and now there are no functions left over. This is the input. So once there are no functions left over, I attach that input to the last function I wrote, and then I close off all the parentheses. So I think it's a good idea to be able to convert this notation to this notation. Show you how we can do this, because this happens all the time. They ask you to do like h composed of h, so taking a function and running through itself. Let's say we compose that with r, and then we compose that with another function f. So we can do this as many times as we want. Okay. I wanted to convert that. Start with the h. Put a parenthesis. So I use that first one. Okay. I get to this one. Use that. Put another parenthesis. I now get to r. Okay. Put another parenthesis. And now I get to f, right? And I've used f. So I've used all of my functions. So that means if I use all my functions, then x must go with that innermost one. Now here's where it gets kind of ugly. We got to close off this parenthesis. If I do that, we got to close off this parenthesis, and we got to close off this parenthesis. So 4 parentheses that are back to back, just closing one another off. But the reason we do this way is because if I look at this notation, that's the innermost function. That's the one I start with. I start with that first substitution, and then it's going to tell me to look at h of whatever that is. Okay. If it's this, I start with that innermost right there. Okay. I think that's hard to recognize. If I don't do that, I actually kind of work backwards out of this phrase. I have to start there, and then run it through there, and then run it through there, and then run it through there, and that's hard to think about, I think. All right. So I'm always going to write it with this parenthesis notation, okay, or convert it to that parenthesis notation as we do these examples. All right, so where does that bring us to our first example? Okay, the first example here, guys, the idea here before we do anything is just analyze the domain. Think about the domain of F. Polynomial, right? So no issues there. All real numbers are or is your domain. Same thing for G, polynomial. No division, no roots. So it's all real numbers. So that's nice. So that being said, when I start finding these composites, there's not going to be an issue with my initial input. I'll always get or have the ability to get an output in that initial situation. So let's find the function f composed of G. F composed of G of X. Okay? The way I would write that is to start with F, and use that one. I'm going to compose it with G. All right, I like to use, or at least with you guys right now, I'm going to use colors because I think it allows you to see. Okay, we're gonna target that innermost function. We're going to target G of X. Okay, so I go pick off G of X, and I replace it inside there. So I'm going to replace G of X with what it was equal to, X minus 3. That makes sense to everybody? Okay. Now we read it and say, what does it tell me? Well, it's telling me take the function F, and as your input, use X minus 3. We'll go up to F, okay, and that's where I'm going to substitute, right? So I let that variable become X minus 3, and then we got that power of 2, right? And that thing right there is the composite function F composed with G. Okay? On the contrast, then they'll ask you to do, a lot of times it's a common theme of questions. Once you do F composed with G, they ask you to do G composed with X. Well, I write that now. It's G on the outside. The inside function is going to be f of x, right? Does that make sense? Okay. So now I'm going to replace f of x with x squared. Does that make sense? Stop me if I'm going too fast. So when we read this, that algebra says, okay, go to G, and wherever you see an input or your variable, okay, replace it with x squared. So when I do that, I should be producing x squared minus 3. And now that is G composed with F. G composed with F. Okay. So here's a couple things they're going to ask. They're going to first ask, what are the domains of these things? Okay. Well, we have to analyze and recognize, okay, the domain of these are first dictated by this original input. Okay. So that original input was all real numbers, correct? So there were no restrictions based on that original one. When I get this one out, when I get that final production, okay, I want to look at that and say, okay, is that telling me that there are any restrictions? Okay, that's polynomial as well, correct? So no restrictions from the original input, no restrictions in the final rule, so no restrictions at all. Domain of this thing is all real numbers. Same thing happens here. Look at f of x, original input, that's x squared, that's all real numbers. When I get done here, there's no square root to division by 0, right? So again, all real numbers. If there were issues, we'll see one here in a little bit, hopefully before we get out of here, that there are restrictions we've got to pay attention to, okay? The next question we're going to ask you is in regards to what do we recognize here? F composed of G does not equal G composed of F, right? So there's a relationship here that we talked about. We talked about it yesterday with addition and subtraction. 5 minus 2 is different than 2 minus 5, right? And because they're different, we say subtraction is not what? Commutative, okay? So compositions of functions are not commutative, okay? And that commutative property, guys, it's pervasive all throughout mathematics. And all types of different things that we do, we're usually asking, is it commutative? Because if it is, it shouldn't matter the order, and that's a nice thing to know, okay? Here, they're not commutative. They ask you to find f composed of g of 5 and g composed of f of 7. Two ways of doing this. I like the rule, okay? If I've got now this rule, got plus 5 in here, what's 5 minus 3? 2 squared is 4, okay? But could I have also done this? Could I have said f of g of 5? It's okay. What's g of 5? So up here, find g of 5. What's that give me there? 2. And now that new rule says find f of 2. Close that up in here. What do I get? 4. So can I evaluate that either way? Okay. I think the rule is beneficial. Again, like yesterday, if I have 4, 5, 6, 7 things to evaluate, I probably want to have that rule. I can develop a table quickly, maybe recognize patterns, that kind of thing. If we see something like this, let's say f is equal to x squared, but g of x is equal to root x. And I ask you to find f of g of x. What's the domain of this thing? All real. What's the domain of this thing? 0 to infinity, right? Including 0. So, here's the idea, guys. If I rewrite this as, f composed g of x, it's going to be f of root x, right? That makes sense? Because that's root x there as my initial input, can I choose a negative number? No. So I will never be evaluating this thing at a negative number. Does that make sense? Okay? Because this initially told me you're not allowed to use negative numbers. So that's why this domain, this original input domain, is important to our final domain. Okay? Because it's restricting what I'm actually allowed to put in inside of that. Okay? So if I write it this way, so f of root x, so now I'm going to go to f, and it's going to look like this, right? Make sense? Now if I evaluate that, or if I simplify that, I just get x, correct? Okay, so my new rule is x. But we got to talk about the domain. There are no domain issues with x, correct? But like we said, this restricted some of our values that we're allowed to check. And I got to keep those, and then I explain what this final production looks like. So the domain of this thing, the domain of f of g of x, is going to equal x values that are greater than or equal to 0. So I want you to look at this. I want you to see this algebraically. If I go to GeoGebra, let's go f of x was equal to x squared, right? All real numbers. I look at g of x, which is equal to square root of x. Okay? Numbers bigger than 0, equal to 0 or bigger, right? If I ask this thing to find f of g of x, You see how it doesn't evaluate it, does it? I keep saying that, simplify it. But do you see that it only graphs the line y equals x for x values that are 0 or bigger? And that's because of the original inputs were only allowed to be 0 or bigger. Is that okay with everybody? All right. Those domain questions, guys, I don't think they jump off the page at people. And we got to do some thinking about the idea of what is this procedure doing? How am I applying this procedure? And what numbers am I allowed to be using in the initial steps of the procedure, and how does that impact kind of the overall thing? Okay, so those are all things to try to wrap your head around. Sent you an email yesterday evening after school with the exam, practice exam key. I tried to go through there and try to explain as many things as I could. To have that to kind of reference over the week. I will be putting another assignment on Math Excel, but it's not going to be our website. It's not going to be due until next week. Okay.